Hello, Math 3 students. If you came to the live lesson today, you heard me talk about how I'm going to be doing videos from now on for both the notes and for the classwork. That way you don't have to come to the live lesson and wait for me, especially if you already know what you're doing. I would like for you to come to the live lesson to get your extra credit points, but the live lesson from now on is going to be maybe a few minutes long, so you need to be on time, but also it'll be more like office hours. So what I will do is I will start the live lesson at the regular time, whether it's 9:30 or 11 for your class, depending on which class you're in. And I will just say, okay, so you should have done the notes on this. Your classwork is a worksheet, or your classwork is an Excel or whatever. And then there will be a video. If it's classwork on a PDF, there will be a video with me going through the classwork. Now, that doesn't mean I'm going to do all of them. I may not do all of them. I might leave some for you to do. But you are responsible for finishing the worksheet. No matter how many I do, you are required to do all of them. There might also be a time where I will say, okay, on this next section, I want you to use purple. Or I want you to use orange. That way I know that you're listening to the video and not just watching it to get the answers. Because it is important that you listen to the instruction as well. If you know completely what you're doing, then you can speed through some stuff. But for the most part, I'm going to go as fast as I can, and that way you don't have to wait for me, and you'll be able to hear my instructions. I don't want to have to put these on Edpuzzle to make sure that you're listening to them. So, okay, so you did some notes on polynomial operations today. This is a review. This should be a review anyway, and so I'm going to go through these pretty quickly. So the first thing that we're going to do is just name each polynomial by degree and number of terms. So of course the number of terms is really easy. You just look at how many terms there are between the plus and minus signs and just count them up. And then of course you remember you had a chart for that. And then also for the degree, all you're looking at is the highest degree. So for example, this 3 right here tells us what degree it is. On number 2, the 6 tells us what degree it is. Number 3, the 5. And then so you look for the highest degree, and I think that's going to be the 6 right there. So don't let it fool you, because it might not be in standard form. And then the 6 right there. Okay, so let me grab my drawing tool. And if you are, whether you're using text or whether you're using the drawing tool, use a different color from black, because it just helps me see your work better. All right, so number 1, if we're naming the polynomial by degree, we look and we see that this is a third degree, but a third degree, if you remember, is called cubic. And then it has 1, 2, 3, 4 terms, and anything above 3 terms, I just say polynomial. I don't say, 4-term polynomial or anything like that. I just say polynomial. Number 2, it's a 6th degree, because 6th degree we don't really have a name for. And that's also a polynomial because it has more than 3 terms. Number 3, this is a quintic, which is also a 5th degree. Quintic, and this is a binomial because it has 2 terms. All right, number 4, also quintic. This is a trinomial. It has 3 terms. Oops, didn't spell it right. This right here is a quadratic. Don't mix that up with quartic. Quadratic monomial. Number 6 is a 6th degree. And this has 1, 2, 3 terms. This is a trinomial. Okay, what I would like for you to do is number 7, 8, and 9. Oops. 7, 8, and 9. I want you to do those by yourself. And I'd like for you to use red to do those. All right, add the following polynomials, write in standard form, descending in alphabetical order. We'll try to do that. I'm not that concerned about standard form necessarily if all you're doing is adding polynomials or adding terms. I'm more concerned with you getting the like terms right. So let's look for our like terms here. These are all addition, so I can honestly just ignore the parentheses. Okay, so I have a j cubed and a j cubed there. I have one j term, and then I have a constant of -2 and -3. And I do like to go ahead and highlight the operational sign as well, because that helps me to know it's a negative I'm adding. Okay, so I have 7j cubed and 5j cubed, that's 12j cubed. And then we have minus j. And then we have a -2 and -3, that's -5. And that's it. Okay, number 11, same thing. This is addition, so just look for like terms. I have an 8a to the 5th and a 3a to the 5th. I think that highlighting these really helps see what we're adding together. An a, and then a -4 and a -2. Okay, so 8a to the 5th, 3a to the 5th, that's 11a to the 5th. Remember, you only add the coefficients together. You do not add the exponents together. So this is 11a to the 5th plus a minus 6. Okay, number 12. I'm going to highlight one more time, and then I'll probably stop highlighting. I might underline something. Okay, I have an m to the 5th and an m to the 5th. I have one m to the 1st, and then a +1 and a -1. So my m to the 5th, so I've got 8m to the 5th. My +9m, I've only got one of those. And then +1 and -1, that's 0, so I don't have a constant out here. So this is actually the answer right here. Number 13. Okay, I have a 3m to the 5th plus 9m to the 5th, that's 12m to the 5th. I have a 3m plus 3m, and then I have constants of +1 and -2. +1 and -2 is -1. All right, let's look at the next one. I have -5x squared, -3x squared, that is -8x squared. And then I have an x there and an x there, that's a -5 and a negative, that's -1. So that's -6x. And then my last one, I've got a +4 and a +2, that is +6. All right, I'm going to do one more. I think I'll do 17 with you, and then I want you to do 15 and 16 by yourself. I don't care what color you use, because you might want to use more than one color anyway. Okay, so let's see. These are kind of mixed up here. I've got a 4j cubed and a -2j cubed. So that's 2j cubed. And then I have a 4j squared and a -1j squared. So that's plus 3j squared. What else do I have? I've got some constants, it looks like. So I have -3 plus 4 and plus 2. So -3 plus 4 is 1, plus 2 is plus 3. All right, now subtraction, we have to change these to addition. And also, by the way, these I don't, like I said, these are, I think these are already in standard form the way I wrote them. Yeah, I'm not that worried about you putting these in standard form as long as you get the terms right. Okay, so number 18, let's change this to a plus, and then everything in the parentheses is going to be the opposite of what it was. So where I have this minus symbol, I just change that to a plus. Same thing here, change that to a plus. So this is a -3, a +8, +2. I think I will go back and highlight some like terms. I've got a -x squared and a -3x squared. A +x, +8x. Again, I like to highlight the operational symbol because that helps me know if it's positive or negative. And then I have a -4 and a +2. Okay, so let's combine those. -x squared, -3x squared, that's -4x squared. +1x, +8x, plus 9x, and then -4, +2, that's -2. All right, let's look at 19. You just have to remember that if there's a minus symbol between the parentheses, that you've got to rewrite that as a addition problem. So change that to plus, change everything in the parentheses. Everything that's after the plus, change everything. So that changes to a plus, and that changes to a plus. And this 5 right here changed to a minus or a negative. Okay, let's highlight again. So I have an 8x squared and a, nope, undo that. That is not like terms. This is the like terms right here. 8x squared and 8x squared. And then I've got a negative 3x and a negative 5x. And then, let's see, got this plus 5. Okay. All right, so I'm going to start with my 8x squared. So that's going to be 16x squared. Then I have my negative 3x, negative 5x. That's minus 8x. And then my plus 5. All right. I'm not going to do all of these either. Let's see. I don't think we'll do these either. You can go ahead and mark this part out. We're not going to do all these. It's not necessary. We will do the multiplication though. So let me choose, I'm going to choose 2 more of these. Let's do 22. So I'm going to do 22 and I'll do 20, let's do 25. And then I want you to do 20, 21, 23, and 24 on your own. All right, so let's see, 22, change this to a plus, change this 5 to a negative. That's going to be a plus, that's going to be a minus, and that's going to be a plus. Okay, let's look for like terms. I'm going to use my highlighter again. Okay, so I have an x cubed term here and here. I have an x squared term here and here. I have one x term, and then I have constants, plus 9 and plus 9. Okay. So my x cubed terms, 3x cubed minus 5x cubed, that's negative 2x cubed. Look, if you don't know what 3 minus 5 is, put it in your calculator. Okay, and then I have plus 3x squared plus 7x squared, that's plus 10x squared. I just want to check something. Okay, it doesn't tell me like to name these or anything. I just want to make sure. What's the next one? Minus 6x. And that's by itself. And then, let's see. Oh, 9 plus 9 plus 18. Okay, so then I'm going to do 25. All right, so this one has 2 different subtraction symbols and each set of parentheses after it. So I have to do the same thing after each minus symbol. So I have to change this to a plus, change this to negative, and change this to positive. So whatever it is, you change it to the opposite. So this was a negative 2, so I'm going to change it to a positive 2. Change this to plus, change this to negative 5, and this to negative x squared. Now let's find our like terms. Let's see, I have a negative x cubed right there, and that's the only one. I have a 3x squared and a negative x squared. And then the rest of them looks like are constants. Plus 7, plus 2, minus 5. Okay, let's see what's first. 3x squared minus 1x squared, that's 2x squared. Oh, next one is, oh wait, sorry, the negative x cubed would have been first. So let's actually write that one first. And then we'll put a plus there. Because if we want it in standard form, we want the cube first. Okay, so that's the x squared. Everything left is constants. Plus 7, plus 2, 9, minus 5, 4. Plus 4. All right, so that's your addition and subtraction. Let's talk about multiplication. So multiplication, some of these are distributive property, which you should have learned a long time ago. Some of them are like multiplying 2 binomials together. Let's see if there's anything a lot harder than that. Let's see. Okay, 34, I'll definitely do that one with you. And then a lot of them are distributive property, and that's really easy. So I do want you to remember, though, when you have exponents, and we haven't talked about this, we really didn't do this in the last unit, but when you have exponents like times each other, you're going to add the exponents together, and I'll talk about that as I get to each one. But so 26, for example, this is distributive property. So this is That's what we call distributive property, which means I'm going to take this 2x cubed. I'm going to take this right here, and I'm going to multiply it times 3x and then times 5. Okay, so when I multiply 2x cubed times 3x, 2x cubed times 3x, I multiply the coefficients, 2 times 3, 6. And then what I do is when I multiply x cubed times x to the first, I add the exponents together. Because this is 2 times x times x times x, and then 3 times x. So how many x's do I have? 1, 2, 3, 4. So this would be 6x to the 4th. If you don't remember that, you'll get used to it. I'm not going to go through every one of them like this. And then 2x cubed times 5, I just multiply the 2 times the 5, and that is plus 10x cubed. So the x cubed just gets kind of tacked on. All right, the next one is 2 binomials. And you might remember from Math 2 using what we call box method. And I like using box method with my students. I think it's like the easiest way to do these, and I'm going to show you box method real quick. And you should have seen it. I should have already done it in the notes too. All right, so across the top, we put one of the binomials, x minus 7. Okay, and if it's a minus, you definitely want to put that minus there. And then down the left side, we put the other one, x plus 5. And then in each box, we multiply either the numbers or the variables that kind of match up. Okay, so this box is going to have the x times x, x squared. This one's going to have the negative 7x. This one's going to have 5x, because 5 times x is 5x, and then 5 times negative 7 is negative 35. And then what I also need to recognize is that this number and this number are like terms. So when I go to write my answer, I need to go ahead and combine those two like terms. So the answer to number 27 would be x squared, which is right here, x squared, and then I'm going to add the 5 and the negative 7, so that's minus 2x, and then the minus 35. Okay, so that is those two binomials multiplied times each other, and this was the answer to the first one. All right, I want you to do 28. I think you can do that one. And we're going to, the 31 and 34, I'm going to probably have to do like on a separate PDF, and I'll show you how to add a page to your PDF if you need to. Okay, so let's go ahead and do 29. So we're going to have to multiply negative 4x squared y times everything in these parentheses. Okay, so negative 4x squared y times x squared. What I'm going to be doing is multiplying the x and the x times each other and then adding those exponents. So that's going to be negative 4x to the 4th y. Okay, because the x's are really the only thing I could deal with there. Plus negative 4x squared times 7xy. Okay, so negative 4 times 7 is negative 28. And oh, sorry, I should write a minus there. Let me erase that. I should just go ahead and write minus 28. Okay, x squared times x is x cubed, and y times y is y squared. And then I've got negative 4 times negative 6. That's positive. That's plus 24. I don't have another x term, so x squared just gets brought down, and then y times y cubed is y to the 4th. All right, I want you to try 30. I also want you to try 32 because that's binomials. And 33 is the same as writing, I want you to try that one too. This is the same as writing 3x plus 5 times itself because the whole thing was squared. So that's that. Okay. Sorry. I'm going to do number, well, that's not going to work for me. There we go. I'm going to do number 31, and I'm going to let you mark out 34. So mark out 34. Let's see, 5n squared minus 3n minus 2. 5n squared minus 3n minus 2. Okay, hopefully I copied that right. All right, so this is number 31. So what you have to do on this is kind of like your binomials, but what is that? Okay, that looked weird. It's kind of like binomials, but these are trinomials. So I actually have to multiply each of these by all three of the terms in the second parentheses. So it ends up being a really long problem when you get it done, and then you just have to combine like terms. So let's start with the 4n squared, and I have to multiply it. I'm going to distribute it. It's like distributive property, but I've got this, you know, these three terms. So let's start with the 4n squared. So 4n squared times 5n squared, that is 20n to the fourth. 4n squared times negative 3n is minus 12n cubed. 4n squared times negative 2 is minus 8n squared. All right, so now I'm done with the 4n squared part. So I can mark that out if I want. Now I'm going to do, whoops, that's the wrong tool. I'm going to do the negative 6n times all three of these. Okay. All right, negative 6n times 5n squared is plus 30, I'm sorry, minus, that's not plus. It should be minus 30n cubed. Negative 6n times negative 3n is plus 18n squared. Negative 6n times negative 2 is plus 12n. Okay, last one. I got to do the 5 plus 5 times all three. I'll just color them this time. Okay, positive 5 times 5n squared plus 25n squared. 5 times negative 3n minus 15n, and then 5 times negative 2 minus 10. Okay, let's see what we've got as far as like terms go. So I have a 20n to the fourth. I don't have another n to the fourth term. So I'm going to just bring that one down in a minute. I have a 12n cubed, a negative 30n cubed, and that's it for the cubes. I have a negative 8n squared, positive 18n squared, and a 25n squared. I'm running out of colors. Let's do purple maybe. 12n and negative 15n are like terms, and then my minus 10 is by itself. It's just a constant. Okay, we're almost done. 20n to the fourth, just bring it down. Okay, so I have a negative 12 and a negative 30n cubed. Negative 12 plus negative 30 is negative 42n cubed. Okay, so I'm going to mark these out as I do them. That way I know I don't need to deal with them anymore. Negative 8n squared, positive 18n squared, positive 25n squared. Well, if I do the positive 18 and the negative 8, that's positive 10, plus 25, plus 35n squared. Okay, so I did those. 12 minus 15 minus 3n, and then, so I'm done with those, and then the minus 10 is the last thing. So that is the answer to those two trinomials multiplied times each other. You don't have to do this part, and you don't have to do number 34, but I do want you to do all the ones that are circled. All right, so I think that'll do it. I'll be in the live lesson. If you have any questions or any problems with anything, you can always pop back in there and ask me questions. I had copied a really long problem wrong. I did it wrong, and then I had to go back and change it. So that's what took me so.
Yeah?
Yeah.
You done?
Mm-hmm. What?
I guess for something to watch to us, you and me.
I
don't want to watch this shit.
What is this?
Starship Troopers. One of the best movies of all time.